Okay, for our homework questions, the first part we are given a graph and an interval, and we need to find our average rate of change over this interval. You do need to remember that these numbers here, those are x values, so you have -5 and something and -2 and something. So for the -5, notice that if we go back 5, then if we go up or down, then you should be able to get to, looks like -2 here. So -5, -2, and then at -2, we should be way up here. And so that looks like that is going to be maybe at 7. So now we're ready to find our average rate of change, which is going to plug into our slope formula. And so when we do that, remember we're going to have 7 minus -2 over -2 minus -5. And after we simplify that, it looks like we should have 9 over 3, which is going to give us 3. Okay, for our part 2, again, same idea here. This is -3, comma, something, and 0, comma, something. And so if we go look over at our graph at -3, when we count back 3, we need to see where we're at on the graph. So 1, 2, 3, 2, 3, 4, 5. It looks like we're way up here at 6. And then at 0, it looks like we're at 1, 2, 3. So now doing our average rate of change formula, then we're going to have 3 minus 6 over 0 minus -3. And so here we end up with -3 over 3. So our average rate of change is -1. We're going to do the same thing here for our next set. So again, we have -9, comma, something, and we have 7, comma, something. And so for -9, if we go back 9, it looks like we might have down here at 1, 2, 3, 4, 5 maybe. And at 7, if we go all the way out to 7, it looks like then we're up here at 3. And again, going through our average rate of change formula, then we will have 3 minus a -5. So that's going to give us 3 plus 5 over 7 minus a -9. And so we're going to have 8 over 16. So my average rate of change is 1/2. Number 4, here again, picking out those values. And so for -2, we should be at -3. And at 0, it looks like we're going to be at 1. And for our average rate of change formula again, we're going to have 1 minus -3 over 0 minus -2. And so we're going to have 4 over 2. And so our average rate of change is 2. Right, now for these problems, our formula is still the same, but how we get our y value is a little different. Instead of reading off the graph, we're going to have to substitute our x values into our function. So we need to find -8, and then f at -8, and then we need to find -5 and f at -5. And so over to the side, we need to find f at -8, and that's where we're going to plug into the calculators. And it looks like we're going to have 64 minus 56 minus 11. So that looks like we're going to end up with -3. So f at 8 is -3. And then we need to find f at -5. And when we substitute that in, we have 25 minus 35 minus 11. And so when we number crunch that, it looks like we're going to end up with negative 21. And so now we're ready to go through our formula. We're going to have negative 21 minus a negative 3 over negative 5 minus a negative 8. And so we're going to end up with negative 18 over 3, so negative 6 is our average rate of change. Number 6, again, same process. So here we have negative 9, and we need to find f at negative 9. And then we have 6, and then f at 6. And so substituting in, again, f at negative 9, if we substitute that in, we're going to have the square root of 7 plus 9, which is going to be the square root of 16, which is going to generate 4. And then f at 6, we're going to have the square root of 7 minus 6, which is the square root of 1. So that's going to give us 1. So now we're ready to do our slope formula. And again, we are going to have 1 minus 4 over 6 minus a negative 9. And so that's going to give us negative 3 over 15. So we should have a negative 1/5. Right, moving along. And all of these problems, same way, we are substituting in. So we have a negative 1. We need to find f at 5. And then we have a 5. And not f at 5. I was looking at the bottom problem. Negative 1 and f at negative 1. And then 5 and f at 5. And so whenever we substitute in f at negative 1, that's going to be negative 1 over negative 1 plus 3. So that's going to generate a negative 1/2. And f at 5, when we substitute that in, we're going to have 5 over 8. So now we're ready to do our slope formula. So we're going to have 5 over 8 minus a negative 1/2, so plus 1/2, and that's all over 5 minus a negative 1. And so adding these together, looks like we're going to have 9 over 8 all over 6. And remember, that is dividing fractions, easy as pie. You flip the second, multiply. And here, that's going to give us 9 over 48, and that would reduce to 3 over 16. Right, number 8, again, we are substituting in our 8 and our 14. And it looks like here we have 8 comma f at 8. And then we have 14 comma f at 14. And so f at 8, we are substituting into our calculator. So we have negative 1/2 times 64. And then we're going to have plus 24 plus 1. So it looks like f at 8 is going to end up being, looks like it might be 7. And then f at 14, what a ginormous number there. Number crunching there, you have negative 1/2 times 14 squared plus 3 times 14 plus 1. And when you put all of that in the calculator, you should end up with negative 55. And so now we're ready for our rate of change. So our average rate of change is going to be negative 55 minus, that was a negative 7, wasn't it? It's going to be minus negative 7, so plus 7, over 14 minus 8. So we're going to have negative 48 over 6, which is going to give us negative 8. Right, so here, whenever we, again, start plugging in, we have 1 comma f at 1. And then we have 5 comma f at 5. And so whenever we substitute in f at 1, it looks like we're going to end up with 1 plus 2 minus 5 plus 3. And so all of that looks like it's going to be a 1. And then f at 5, if we plug that in, we're going to have 125 plus 50 minus 25 plus 3. So that one looks like it's going to be 153. And so again, for our average rate of change, we're going to have 153 minus 1 over 5 minus 1. And so that's going to give me 152 over 4, which is going to be 38. And number 10, let's see. I'm going to go ahead, I think y'all see the pattern, and just show f at -1. So when I plug in that, then we are going to end up with 1 over 1. So we should just get a 1 there. And then f at 10, when we plug that in, we're going to have 100 over 12. And so that's going to reduce down. We could take out a 4, so that's going to be 25 over 3. And so now our average rate of change is going to end up being 25 over 3 minus 1 over 10 minus a -1, so that's 11. So that's going to give us 22 over 3 over 11, or times 1 over 11. So that's going to reduce down and give us 2/3. Our next problem, again, looking at this, it looks like f at -2 is probably going to generate a -4. And nope, let's go back and change that. I don't think so. Let's plug in. So we're going to get 1/4 times -2 to the 4th. That's what I was thinking about. And that's going to give us 16. And then minus -2 all cubed, that's going to give me a -8. So that's going to end up giving us a 12. And so f at +2, so when I substitute that in, we're going to have 1/4 times 16. And then here it's going to be -8. So that's going to give us -4. And so now whenever we go through our rate of change, we're going to have -4 minus 12 all over 2 minus a -2. So we have -8, or not -8, goodness. We have -16 over 4. So our rate of change is -4. Okay, so for our next one, f at 0, looks like we're going to end up with the cube root of -1, which is -1. And then f at 7, we're going to end up with the cube root of 28 minus 1, so 27. So that's going to give us a 3. And so when we go through our average rate of change, we're going to have 3 minus a -1, so 3 plus 1 over 7 minus 0, which is 7. So our average rate of change is 4 over 7. Okay, so for here, we are going to have f at -3. And so in the numerator, we're going to have -6 minus 1. And then in the denominator, we're going to have -3 plus 4. So this one looks like we're going to have -7 over 1, so -7. And then f at 8, when we plug in, we are going to end up with 16 minus 1 over 12. So that's going to end up giving us 5 over 4. So now we're ready to do our slope formula. We have 5 over 4 plus 7 over 8 plus 3, so that's 11. So we're going to end up with 33 over 4 all over 11. And so that's going to reduce down to give us 3 over 4. And number 14, our slope formula here, let's go ahead and substitute in a -9. And if we plug in a -9, we're going to end up, and we're plugging in each part here, you should end up with a -326. And then f at -5, when you plug in a -5, you should get -2. So our slope formula, you have -2 minus a -326 over -5 plus 9. So we're going to have 324 over 4. So this is going to be 81. Okay, so for number 15, the average low temperature by month in Nashville is represented by this function. And so we know that X is the month. Find the average rate of change from March to August. So from March to August, we're going to say March is our 3rd month and August is our 8th month. So in other words, we have 3 and we need to find F at 3. And then we have 8 and then we need to find F at 8. And we're going to find that by plugging into this equation here. And if we do so, then F at 3, when we substitute that in, F at 3 looks like it's going to generate 46.1. And then F at 8, when you substitute that into this function again, you should end up with 64.1. And so now for our average rate of change, we're going to have 64.1 minus 46.1, and that's going to be all over 8 minus 3. And so that's going to give us 18 over 5, and that's going to be about 3.6. And this, what was the units? It's temperature by month, so it's going to be 3.6 degrees per month. Okay, now let's go look at number 16. A rocket was launched in the air from a podium 6 feet off the ground. The rocket's path is represented by this equation. And so where h at t is the height and feet and t is the time in seconds, find the average rate of change. So again, right here, average rate of change. So we know we're still doing our same formula from the initial launch. So that initial launch was going to be at time t0 to the maximum height here. So what we can do to find this, let's think about the path here. So if we have this equation, we know this is a parabola that's turned upside down. So it's going to look something like this. That's the path. And of course, there's the ground. It's not going to drill through the ground, thank goodness. And the initial height here, we need 0. So I need the ordered pair 0, h at 0. And so if I plug in 0 for my time, that's going to generate the ordered pair 0, 6. And then for the other part, we need to try to find what was the maximum height. That's going to be way up here. And so we're going to have to try to figure out what's going on up there. So that's really, if we knew what the zeros were of this, then we could cut it in half and be able to find what our x value is. So let's see if we can't do that. Here, if our height is 0, so we could factor it, but there's another formula. I forgot about this. Let's do our negative b over 2a. That's going to be our formula to find our x value right here. I didn't think about that. This is going to be a little bit easier. So 120 is your b value over 2 times a, which is negative 16. So if we number crunch this, put this in your calculators, you're going to get 3.75. So now I need to go find that, because this is my other x value. So I have 3.75 comma something. So that something is f at 3.75. And if you put that into this formula right here, it looks like you're going to end up with about 231. So here's our two points that we need for our slope or average rate of change. So let's calculate average rate of change. So we're going to have 231, this y value minus this y value. So 231 minus 6 over 3.75 minus 0, so 3.75. And please use your calculators here. And it looks like you should get about 60. And then don't forget your units. That's going to be feet per second.